Hello, I'm S, and in this video I want to work with NRF 24L01 version for NRF. Okay, I prefer open the Nordic datasheet and talk about a summary of thing I know and I understand when I study this datasheet. At first, if you want have more information about this module, you must work on it and study all of the Nordic datasheet. At first, this chip work on 2.4 gigahertz until 2.5. This is the frequency of its work, and it is free to use every person. Go to page 8. I highlight some important point in here and I use in my program. At first, this is the feature of that NRF 24L01 worldwide is, as I say, 2.4 gigahertz, and this is the rate for transfer data between TX and RX, 251 and 2 megabit per second. And the other thing I was mentioned to it is about the protocol called Enhanced Shock Burst, or ESB. Uh, ESB means, for example, 1 to 32 byte dynamic payload length, automatic packet handling and auto packet translation handling, and 6 data pipe multi-severe for 1 to 6 star network. This means when we transmit data between the transmitter and receiver, in this module we have 6 pipe. Pipe like way the transmitter and receiver go there and stand there and talking, or for example sending data at the same pipe. I mean the address of at the address of pipe in two project, I mean in receiver and transmitter, it must be same. And the next thing about is payload. Payload is the box or something like that. I will show which is it. We can put it on a string and send it on receiver, and receiver see that and unpacking the data for transmitter. This is the summary of enhanced shock burst. Shock burst. Uh, Another thing is important, page 24. Page 24. Uh, I will mention to RF channel frequency. As I say, this chip work with 2.4 gigahertz until 2.525 gigahertz. And when we choose the channel, I will show in the video, we must plus RF underline channel megahertz, and I mentioned in that point in our program. The next thing about 26. Yes, 26. Enhanced shock burst. As I say, it is a packet-based data link layer that feature automatically passed assembly and timing automatically, and so blah blah blah. As I said that. After that, page 27. Okay, this is the overview of shock burst, enhanced shock burst. Uh, this is the format for package. The first partition for preamble, and the next for address between 3 to 5, and the next is packet controller field 9-bit, and we have payload in here. We must put in data in here and send it to receiver. Okay, and 38 is the last page I want to explain about that. Okay, as I say, we have 6 pipe in here. Every pipe has a spatial address. And when we talk between the receiver and transmitter, we must set or synchronize these two address. This is the uh, addressing data pipes. And at the same time, we have 6 receiver with 1 transmitter. This is really important and interesting feature of this module. Okay, that's enough. If you want more information, you you must study this completely latest. Okay, go and I will mention that my circuit. Okay, let's move to schematic of circuit. This is the first part for transmitter. As you see, I work with this module. We have 8 pin here, MISO, MUSI, and SCK is related to SPI protocol, and IRQ is not using this project. And this is really important. When we compile this project, we must add this capacity in here, and the capacity of that I wrote it under between ground and uh, supply voltage. This is really important. I offer you install this capacity in here is 1000 microfarad and 10 volt. It's the power to voltage. This is really important for the circuit. I put it this push button here. When I put this push button at the transmitter, something transferred to the what's that receiver. And the next is about receiver. This is the receiver circuit. Uh, Again, I use this capacity because we have a noise in the air, and when we don't use it, when we push the push button, it's not exactly what happened we expected in our circuit. Put this capacity in here with the feature. I write it. Okay, this is the RX circuit. Go to the CubeMix and make the project. As you know, we have 2 circuits. One of them for fix, and the other one is for receiver. Okay, I choose my micro F103 V8. Okay, go through the system. RCC is what's that? No. Okay. And go to clock configuration, change to maximum clock in here, and then in transmitter I use UR2. Go to UART is mode asynchronous in here, and the parameters don't changing in here. And next I use SPI1, mode is full duplex master, and change to prescaler 32. After that, go through the pin configuration and PB8 is output and PB9 is output again, and I label them, for example, PB8 for what's that, CSNPIN. It's for SPI protocol. And the next one for C, what's that, C pin. This pin for chip enable on this module. As you know, when we the chip enable is active, this is different when we don't active in here. Okay, and we need to input in here. For example, PR PA1 is input for push button, for pull up push button. And the next one, we do it, we go to RCC, we use UR2 SPI1. Okay, go to project manager, use the K, for example, NRTX, and the name of project is NRTX. Okay, everything is alright, and generate the project. Open the project and close the CubeMX. Okay, this is for TX, and again we go to the CubeMX and make RX project. F103C8. Okay, come on, go to the system, change to serial wire RCC. Last part, clock configuration, like same as project. I do it, change to maximum, and then go to connectivity. This part I use UART1 is asynchronous, and SPI2 full duplex master, changing here to 32. Okay, go to pin configuration, and PP13 is output for LED on and off in our project. Okay, and PA8 and PA50. PA8 is output. I label them. PA8 is CSN pin, as I say, is related to the SPI protocol, and PA15, label them C pin. Okay, everything is alright, and go to the project manager, copy all the necessary library, choose the RX. Okay, choose the NRF RX. Okay, then choose the K, and make the project, generate the code. Oh, forget the name of project. NRF, no, what's that? What's that? NRRX. NRRX, the name of project. Okay, located that and generate the code. Open the project and close the QMX. And this is the project for RX. Okay, go back to the file tx and add these three library, both of them. Open the folder of project tx, go to the core and add this part to in. Copy and paste. Okay, paste it in here, and the next part, copy two hex file and use there. Okay, it's for tx. And the other for RX, again, do this work, copy two hex file in here and copy this file in here. Okay, and go to the kale and add this library, change the name to lib. Okay, and right click here, add existing file to group. The next part, go back and add this part. Okay, go again, open it and go to header file.ho. The next time, go to RX projects and right click again, add group. It's called lib again. Right click, add existing file, go back SCR and close. Okay. And again, open the hex file. Okay, uh, well, I used to do this project and now I wanted to add some right note in here and then explain about what happened. Okay, okay. Add this include to this project. You can use this. And the next, add this variable. This is a TX pipe address. As I say, we have the same pipe for receiving and transmitting when we transmit data. And the next part is about initializing of this NRF module. Where is it? This is the for NRF begin P P8 and PB9. One of them for CSN, the other is for C pin, and this is the pipe address and the channel I use. This and payload size 32, as I say, and go to begin. Add this file. Okay, I write it three form for transmitting. This first part is for pressing the push button in PA1, and we have on we must LED on the next board, I mean receiver. The next part is for transmitting the data or string to receiver, and the last part we transmit the data with full of information. I mean when transmitter transmit data to receiver, receiver what's that back information to transmitter. It's called acknowledge. This is you can use this part for transmit data and see the acknowledge of receiver on uh, transmitter. Okay, anyway, go the debug and ticket reset and run in here and compile the code. Okay, we have 0 error and 6 warming. Warming is not important. Go back to RX project. Yeah, this is RX project again. Uh, and this is the form of RX project. As the last project, we must add this include our project and the next part for begin 0. It's this is really uh, important. This the we have the same address pipe in here, and we have 5 byte 1, 2, 3, 4, and 5. Because we use these pipe 0. This is it. But when we use the, for example, pipes 2 or 3, we have 4 byte. It's really important. I want to uh, point that this part. Okay, the next part is about initializing of this. Go to begin queue and let me explain about a little. Uh, Instead begin, we use PA15 and PA15 and PA8 for C and C speed and write that. This function is for that. Use UART. You can see that on your project if you want. It's not important you use that. And this is the comment print radio setting. This what's that? This right or this function is printed any default of the NRF. You can use it on the project or not. It's not necessarily use that. Then start listening, read the pipe, and this is for acknowledge for receiving data, and the other one is for the in last project. Okay, again we have two type of project. At the first, it for the realizing the push button and on or off LED in our board, and the next one I comment here for receiving a string from transmitter. You you want to try if you want to try it, you can uncomment in here and comment this part and see the data on UART. Okay, compile. Wait a second, go. Okay, wait. Okay, 0 error and 8 warming. Warming is not important. Then go through the. Excuse me, I forget something in receiver. Tick it here and again compile the code. Okay, go to transmitter and because I use both programmer, I must uh, choose one of them. Okay, this is for transmitter. Click here, load the board. Okay, and the next part for receiver. Go to debug, flash download. Oh, excuse me, debug and change this. Compile the code and build on the project. Okay, let me show my board and what happened in my board. Okay, in the video we have two board in here. One of them for transmitter. I mean, this is the first part, and for the transmit data, and I use this NRF as you see there. This is it, and this is the push button in here, as I say. And the next one is that blue pill pin for receiving data, as you see there. This is the second board. Okay, I put this push button in the transmitter, and you can see the LED on in receiver. This push button, it's for transmitter, and this is the receiver board. You can see when I push it here, LED is on here. Okay, go back, and this is the capacity. As I say, you must install for work better your circuit. Uh, okay, thanks for Hamid Yakub uh, channel. If you like my video, please subscribe my video. If you download this project, please send me message and I send this code for check this NRF. Thanks and bye.